Wow, that video is gonna start with that insanely, dramatic groan. Oh, we have math class! Oh,
yeah, let's go math class!
Help us all.
Alright, we have 9-1 today. God help us. God can't help you with
Did
your
you hear
math.
my enthusiasm? Did you hear that? Let's go.
Can I hire somebody to what?
When you're
Yeah, but you have to pay money. It depends on what your job is. But if your job is to do math, you'd probably lose your job if you couldn't do math. Alright, up here. Hey, hi, hello.
Hi!
Welcome. What's up? So, we're in an awkward place because it's Thursday and we're starting a new chapter. But here's our goal. Our goal would be to be taking this mastery next Friday.
What?
I'm not saying that that's what has to happen. We've got a 3-day weekend. We can get through 9-1, 9-2 before you go to the weekend. And this chapter is only 5 sections. So it's going to be pretty quick. Also, this chapter is identical to chapter 8 with one minor change, which we'll talk about in 9.2. So 9.1 should move pretty quickly. We'll probably get to 9.2 also today. The homework is combined regardless of what we get through today. You need to put time into the homework, whether you submit it or not. You need to put time into solving the problems that you're able to, and bring me any questions that you have tomorrow. So we have our friend, our superstar athlete, and he's kind of jerky. I think she put the extras over the top. You got one? So, he says, I'm going to zoom in a tiny bit. So he says, you can take your top 3 runners. You can take 5 seconds from your time. So they pick the best 3 people. And he says you can take 5 seconds off of your time, which in a 100-meter dash, 5 seconds is a pretty big deal. Yeah, my runners know what I'm talking about. And I will still beat you. I'll still be faster. So what we have to start with, if we set up our verbal, is our, let's just call him star runner. Our star runner says he's going to be faster than you. So what does that mean? His time, if he's going to be faster, how's his time compared to your time? Justin?
5 seconds. Wait.
Well, will his be more or less?
Probably less.
Yeah, if he beats you, his time is less than your time. But he doesn't just compare it to your time. He takes it one step further and says, it can be your time. And then you were saying what?
5 seconds.
So, he says you can take 5 seconds from your time. So if I take 5 seconds from, hey Zion, where did papers go when you turn them in?
I don't know. I'm not turning it in.
Well, what? So why did you just put this here?
I don't know. Miss Pettigrew said to.
No, come here. Where do papers go?
In that little.
Yeah, never ever on my desk. So why,
Okay.
when you walked in here, did you completely forget that? Papers go in the bin, regardless. Never on my desk. So it's not just your time, it's your time minus 5. He's letting you take 5 seconds off your time, which is kind of like when people give each other head starts. So, what do we know here? What else could I fill in? CJ? There's something else in this problem setup that we've not used yet. Abby?
I'm pretty sure it's either the 9.95 seconds or it's the 100 meter time.
It is the 9.95 seconds. What do you
Yeah.
think that is indicating?
Is it indicating stars time?
Yeah, that's when he crossed the finish line was 9.95 seconds. So we can fill in, if I get off a highlighter, 9.95 is going to be less than, let's just call this capital T for your time, minus 5. to start working towards, and there's only one step here, getting my t by itself, we got to undo what's attached with it. What is attached with my t? Aiden? A -5 or a -5, depending on how you look at it. Regardless of -5 or -5, how do we get rid of it? +5 or add 5. So if I add 5 on this side, I have to add 5 on this side. And this becomes 14.95 is less than t. Or if I flip this around, please write both ways. T is greater than 14.95 because if I flip it around, I have to flip everything, including that inequality symbol. So when I turn this around, my inequality gets turned around. So what that's telling you is the times of these people that he did beat are greater than 14.95 seconds.
I was like, oh, is that 10? I'm like, no, he canceled it out.
So if one runner doesn't fail, what could that runner's time have been if he was actually successful? Justin?
Wait, never mind.
If that runner was successful at shutting up the superstar, he actually did, like the superstar did not make good on his statement for this one runner. Well, for us, like us, the not superstars, to lose, our times are greater than 14.95. So if somebody was going to not lose, Andrew?
Star's time would be greater than their time.
Yeah, the star's time would be more, or we know that t would be anything not greater. So, like, if
It could be like
t was 14, then 14 minus 5 equals just 9, and that would be faster than the star. So the one person who's successful does not fall in this range. These are all the people who failed.
Wait, were we not supposed to write if T was 14?
No, you can, but that's for the one runner who won, who did not fail. So you want to relate that, highlight or circle that it relates to the runner who did not fail.
Yeah, because I circled that and blue.
When we discuss inequalities, what's the elementary way to remember this that we still use in middle school? What do we reference in regards to those symbols? Casey? Alligator mouths, or whatever mouths. So, what am I going to want to eat? The bigger, right? If I have, like, a little pint-sized, like, chipmunk over here, and I'm an alligator, not me, or I have, like, a fox or something, I'm going to eat the bigger thing. I'm not going to waste my time going for the small thing. So whichever way it opens up is the bigger side. So I could write 1 is less than 3, but then I could turn that around and say 3 is greater than 1. Now, what changes when I add that little line underneath? CJ? It's the or equal to, so please highlight or notate that somehow. These then have the or equal to. So that would be like when x, sorry, highlighter, come on.
Is that like when you have like a variable?
Yeah, when we involve a variable and we say, so like let's say your lunch could be less than or equal to $3. If you brought $3 for lunch, you could spend less than or equal to $3. Now, if I was going to a concert and they told me the concert ticket is $40, I know I'm going to spend greater than or equal to $40, so I'm probably going to buy some food there and a drink there and stuff like. So I know I'm going to spend equal to 40 just to get into the concert, but then I'm probably going to spend some more.
So
And not equal, any things that aren't equal. 1 is not equal to 3, so I'm going to use the not equal symbol. Yeah.
So can you use like less than or equal to, or greater than equal to, or equal to if you're like making it like, are those kind of like when you kind of have like that assumption problem? If, like,
Those are
spend
used.
40 and but you think you're gonna spend more than 40.
So those are used in situations where we say like at least a certain amount or at most.
Or like about.
So this would be I'm going to spend at least 40 because I'll spend 40 or more. This would be I have at most $3 to spend. I can spend all of it, but I don't have to. I could just spend some of it. So this would, and actually that would be really good to write out to the sides here. If I was you, meaning you should do this, this is at most, if I can write today. And this is at least. So at least 40, at most 3. Now we get to graphing this. So one thing that is really beneficial, especially if you struggle with math, is making a model. Anytime I can draw a picture to make sense of something, it's going to help my brain. Regardless of whether you're artsy or not, regardless of whether your picture looks like a 2-year-old drew it, it will help your brain. My pictures look like a 2-year-old drew it.
No.
So, this inequality represents x is less than 3 because the open dot, and I would highlight this stuff, shows that it is not a solution. So, open means not a solution. Getting a little dyslexic there. If the value is a solution, like x is less than or equal to 3, then we use a closed dot because whatever is shaded is solutions. So one thing that will help you remember this, is shaded equals solution. So if it's shaded, it's a solution. So anything here that is shaded, and the arrow tells me it keeps going all the way into infinity, into Goldring's room, out on a snot. There's infinitely many numbers that way. All of them count. All of them work up until 3, and that's the last number that works. 4 will not, because it's not shaded. Any questions? Yeah, you should have done a little bit of this last year. But now we use our algebraic skills to solve problems related and then graph it. Even though I was a percussionist, I do have decent hearing. So, one of these is unlike the others. Have you ever played the game like, one of these things is not like the others, one of these things. You know what I'm talking about? No?
What?
Yes?
Yeah, I know what is that?
I forget.
Yeah, it's like, you guys might be too young for this, but it was like a kid's game where you have to pick out the thing that doesn't fit. So you'd have like a parrot, a parakeet, a cardinal, a fish. Like, that's the really easy kind.
Totally.
But so, we gotta write inequalities for these and find out which one doesn't fit. The cost for internet starts at, underline starts at, $30 a month. So if it starts at, then we're going to say C, the cost, what? If it starts at 30, could I pay $30? Yeah, it starts at 30, right? So it could be equal. So draw the line for could be equal. And then what, Andrew?
Wait, could
There's the other months. It's per month.
Okay, but so hold on. So this is if I get the basic, crappy, slow as molasses internet. This is what the cost for internet starts at. So don't think about multiple months. We're still talking about 1 month. So I get the crappy internet. I can't even stream Netflix. So I get mad. I call WoW. I say, I need better internet. And they say, well, it's fine, but what's going to happen to my bill if I get better internet? Glenn?
It'll increase.
So when I look at what inequality symbol I'm going to use here, my cost could be equal to 30, or my cost could be... Flip to the front if you need to look at them. Greater than, because C could be 40, or 50, or in my case, 120. I'm about to change cable company because they just jacked up my
What
bill.
cable do you have?
So normally for the first year of a contract, you can get like a really good price. I'm beyond that first year. My first year I was paying $65 for cable and internet, like TV and internet. Now, with taxes and everything, it's $130. It's almost doubled. So it's time for me to change cable companies again.
Wait, do you have a WoW?
Can't I just what? You can, yeah. Like, I've never had DirecTV, so I might go to DirecTV next to get their new client discount. So guys, this is why I'm teaching you what I'm teaching you. So you understand, like, when my bill goes up, screw that, I'm going to go find a better price. And you understand the math to figure out where's the best price. I'm trying to save you guys money.
What's your old cable?
Wow. You traveled more than 30 miles today. You traveled more than. Underline more than. Could I, Kylie, could I have traveled 30 miles? If I went more than? No. So, my travel can't be equal, but it could be, like, what's the inequality symbol I'm going to use here? Greater than. Snap. I think I already found out that these don't match. So let's keep going and figure out what the other ones, what inequality symbols they use. Bella, that's funny, you guys are beside each other and in cards beside each other. If I look at the graph down there, let's just say x because x is our favorite variable. Can x be equal to 30? Is 30 a solution here? Hey guys, you know when I call on people, that means I'm talking to them and wanting answers from them? So Bella, what do you think? Is 30 shaded? If it's shaded, is it a solution? So x could be 30, or what about all the other solutions, which you can't really see that well on your paper, so you might need to glance up here to see what's shaded. If I was you, please shade this in so you can see it better on your paper. So it could be equal to 30, or it could be more than 30, because all those other values shaded are more than. And a number n is at least, there's that at least word, n could be 30, but it could be more. So the second one is the one that does not match. Now, this one is correct. Like, the work we did is correct. It's just not like the others. So you don't have to cross it out. It says cross it out. You don't have to cross it out. Just make sure you notate it's not like the others because the inequality symbol is different.
Because that one...
So just what? Yeah, it doesn't match the set.
Is it because...
So all of these are greater than or equal to. This one isn't. So it just doesn't match the set.
So is that because you can, like, find, like, the final answer for that
It's
one?
because 30 isn't a solution. All the other ones allow 30 to be a solution. Yeah. The second one, 30 is not a solution. It doesn't match.
And, like, it says you traveled more than 30 miles. It doesn't say at least or, like, starts at 30
Right,
per
now,
month.
to correct something you said, none of these can I find an answer. Right now, all I know is my answer could be 30 or more.
That
Could
one
be
is
more
just
than 30. Could be 30 or more. Could be 30 or more.
Yeah, that one's just, it, like, pretty much has to be more than 30.
So, write this inequality. You drink, let's just say D for drink, less than 2.5 cups of water today. Which, like, you're going to die if you keep doing that. You need to drink at least 8 glasses of water. And a glass of water is 2 cups, especially you guys. So, to stay properly hydrated, you should be drinking 2 of these a day. Minimum, to stay properly hydrated.
At swim practice, I fill up that water bottle 3 times.
Yeah.
A day, and it's like
So,
2 hours.
if I, Anthony, drink less than 2.5 cups of water, I'm going to start with D. What's your inequality symbol there, then? Yeah, that's pretty straightforward. It's the less than symbol. And then 2.5 or 2.5 or whatever you want to put. So now in this next example, we have q minus 2.2 is greater than some value. So Shane, if we want to work towards getting that q by itself, what would I do? Yeah, if I want to get rid of a negative 2.2 or a minus 2.2, I add 2.2. That gives me that q is greater than 16. Don't forget to carry that 1. Now, I want you to try to graph this on your own real quick. Make sure you're working in pencil. If you're working in pen or highlighter, please be careful because you want to wait and see what the proper one is. The first step to graphing is really easy because it's kind of told to you. Hayden, what's the first thing that you're doing as you go to graph this? What do you... Oh, no, we're still on the example. We want to graph this. So we need to communicate the q is greater than 16 on the graph. So if I'm trying to shade possible solutions, where should I start working? Hayden? Yeah, at the number we're talking about. First thing we always do, put a circle around that number. Then we decide, Bella. So you're one step ahead of me. The second thing we decide is my circle open or shaded? Now Bella skipped that step because she knew, is your circle open or shaded here? Open, because 16's not a solution. So if you can't think of that, write it down. 16 is not a solution, and therefore not shaded. But everything bigger than 16 is, so like Bella said, we go this way and shade everything bigger. And then we draw an arrow because it will keep going to infinity. Love it. I was on the rock wall the other night, like working, and this kid, I was teaching him about the auto belays. He was like, so, can I fall? And I said, well, yeah, you can still fall. Like, if you ever climbed on an auto belay, it like just lowers you slowly. And I said, yeah, we like to say that it's falling with style. And he was like, oh, like Toy Story.
I don't like those. So scary.
Auto belays, they're sweet.
Yeah, my coaches always tell me not to go on those because I'm so scared. I just climb back down the wall because I don't like letting go.
That's fine. I mean, climbing down the wall is a good workout. I mean, I do, I like climbing with a belay better because they can let me take a break.
Yeah.
You're on Team Vertical, right?
Yeah.
Yeah, so you know what I'm talking about. So, one of the things I want to encourage you guys to do is when we start with problems where the variable comes second or last or whatever, flip it around just the variable side so that the variable term is the first thing that happens. So to do that here, I'm just going to take my positive r, write it first, and my positive 8 and write that second. That will just make the solution process easier for you. Nothing else changes. It's still less than or equal to 22.5. So then, oh, that's funny. Julia, you're on top now. What do I do to get r by itself?
You have to get rid of the 8 by dividing both sides by,
Ooh. Dividing? How? Like, so what is the 8? It's a positive 8, right?
Yeah.
And it's held with it through addition subtraction.
Subtract.
So we use addition subtraction. Since it's positive, we subtract. So we subtract the 8, subtract the 8. This gives me r is less than or equal to 14.5. First thing we do, find the number, put your circle. 14.5. Be careful. Lots of people like question which side it's on. Is 14.5 between 13.14 or 14.15? 14.15. So your circle goes between these guys. Is it, Flynn, open or closed? Do I shade it? What determines when I shade it? Check where we put, was it on the front where we talked about which was shaded and which wasn't?
If it's open, it's not a solution, but when it's shaded in, it is a solution.
So, is 14.5 a solution here? Here's the other trick that I think can help you. Do I have to write more or less on the less than symbol or the less than equal, compare these. Which one do I write more? Is it like more work? Writing the or equals, right? I have to write an extra line. When you draw the extra line, you have to shade in the circle. So when I write more here, I shade more here. If that helps you remember. If it was just like this, it wouldn't be shaded. But when it has the or equal, it is a possible solution, and it is shaded. So then, Flynn, if r is less than or equal to 14.5, which direction would I shade?
That way.
So left or right? Sorry, you're sitting at a weird angle for me.
Yeah, left.
Left, because I want values smaller than the 14.5, because my gator's going to eat this. It's the biggest thing there, so I shade to the left. And you don't have to shade the whole way. If you draw the arrow, that tells you that it keeps going. Any questions? Do we kind of see how this process is the same? We just have to pay attention to the symbols between. If there's addition, we subtract. If there's a negative value or if there's a subtraction, then we add. If you've traveled, you've probably experienced some of the joys of checking in your bags.
Yes.
So, airlines... Alright, my computer's spazzing out. Let me pause in screen. Okay. Now I think we're okay. So, airlines restrict baggage to 80 pounds, and this is actually a lot. That would be a good airline. To 80 pounds per person. You pack one 42-pound bag. How much can your second bag weigh? So if they say they restrict it to 80 pounds, what does that mean? Like, could my baggage weigh equal to 80, or would it have to be less? Casey? Yeah, I can have a bag, or my bags, up to 80 pounds is okay. Anything more, I'll pay extra. So my bags have to be, could be equal. What if they weren't equal? Would they be more or would they be less? If they weren't equal, would they be more or less? Easy. Less, right? Because if it's more, they're going to charge you extra. So my bags are less than or equal to 80. Now fill in what we know. I know I've got a 42-pound bag. I've got a second bag whose weight I don't know yet, but combined, they have to be less than or equal to 80. Michaela, what could I do to get the W by itself? Or what do I want to get rid of? Yeah, subtract what? What number are we trying to get rid of? Sorry. What? So, yeah, we want to get this by itself, right? We're solving for this. So to get it by itself, we got to get rid of the 42. So that's what we subtract by. So we take away the 42 to cancel that out, and we have to do it on the other side to keep things equal. I get that W, the weight of my second bag, will be less than or equal to, 38 pounds. Any question? Justin?
Is there an easier way to do that? Just like add 8 and add 30 pounds to 42. Yeah, that's what I do.
Yeah, I mean, that's fine. I mean, but you'd still have to be able to write out the inequality, because it wouldn't just be W equals 38. Your bag doesn't have to weigh 38. Your bag can weigh 38, or it could weigh less. So you can figure out the number on your own, but you got to be able to write out the inequality that it results in. So if you can't figure out the middle term, work back up and kind of start with your verbal and then go from there. Any other questions? Will you do me a favor and go to the black and white printer in the library and grab the stack of math notes on there? Thank you very much. All right, last question on here. A number, do we know what the number is? No. So a number, make your number, minus 3 2/5 is more than, so greater than, 17. What do I need to do to get my x by itself? Xavier?
Are you adding, to,
Sorry, I don't know why that's so loud where it is. It needs to be on paper.
so you have to cancel out the subtraction?
I have to cancel out the subtraction, or I can think about it, thank you very much, as canceling out the negative, because remember we can look at it as subtraction or a negative. So how do we do that?
Well, obviously the subtraction is
Yeah, so we just add on both sides. What do we add?
3.
We just add 3 2/5. I want to remind you guys of something. This paper hole puncher has a slidable adjuster. Please, if you come up here, make sure it's at the 11. Otherwise, your holes are going to end up in the totally wrong place of the paper. So it's adjustable for if you had a different type of notebook. But go ahead and here add 3 2/5 to both sides. Go ahead and show that on your paper. And then we're going to end up with x what? How does x compare then? Who can tell me their answer? We end up with x. We still have the same inequality symbol. What do we get on the right-hand side? What if you add 3?
20.
We get to 20. So then you add the 2/5, we get 20 2/5. Now we could check our answer with any number in this range. So guys, checking inequalities is way easier. Pick a super easy number bigger than 20 2/5. You know what I'm going to choose? 100. Because it's super easy. 100 minus 3 2/5. Is it bigger than 17? Yeah, works. True. If you want to get more specific, get closer to this number. But right now, what we have works. That is absolutely correct. So I want to give you guys a little taste of 9.2. We're not going to get all the way through it today. But in 9.2, we change the one thing that is different from solving equations and inequalities. There's only one difference.
What is it?
Scroll. Go down to the bottom of the front. The multiplication or multiplicative property of inequality. Notice it's inequality when we please highlight when we multiply by a negative number. Now remember, multiplication is division. Division is multiplication. So this is actually talking about either multiplying or dividing. Multiplying or dividing. So please, under this, write or dividing. Here's what we're talking about. I'm going to give you a separate example from them. If you have that the opposite of 2 times something is greater than 8. Yeah, go ahead and write this off to the side here. You have the opposite of 2 times a number is greater than 8. From our work with equations, what would I do to get the x alone? Abs?
Divide it by positive 2.
Abby identifies that this is multiplication, so you need one of these for the other room. I just prepared them, so I have the extras right here. But be careful. What number is it that you got to get rid of?
You have to get rid of
Yeah.
2. Or wait, no. You would have to make it by -2.
So we got to divide by -2. Here's where people screw up. This flips.
Whoa.
When you divide by the negative, this now becomes x is less than
A little back.
-4. When you multiply or divide by a negative, the inequality sign must reverse. So I would highlight this right here. You must reverse the inequality sign when you multiply or divide by a negative. That's the only difference. Otherwise, it's all exactly the same as equations. So let's look at a couple examples. We're going to go back to the top of the notes. But I just wanted to make sure I pointed that out so you guys would be able to... Oh, they're on you guys. You got it. We're moving in. Oh, do you need another one? Are you taking notes for Izzy too? Yeah. You're awesome. So, let's go back to the top of the page. Look at some of these problems. I can't get used to the new software, man. It's like I had an upgrade and it took me backwards. So, this rule shows you about multiplication division when we just have positive values. So, if you have -5 is less than 10, and you then decide, what happens if I triple both sides? Well, if you triple a negative number, it gets further negative. If you triple a positive number, it gets further positive. And you end up with -15 is still less than +30. Because when you just multiply or divide by a positive, nothing changes. I mean, the numbers change, but the inequality symbols stay where they are. If it was multiplying or dividing by a negative, we flip the middle symbol. And actually, guys, that happens with equations also. But what happens when you flip an equal sign?
It still stays equal.
An equal sign is an equal sign is an equal sign all day long, no matter how I flip it. So, if we go to the Columbus Zoo and meet up with my buddy Mike, I got friends all over the place, guys. When you go to college, you'll realize how big your friend group gets. So my buddy Mike works at the Columbus Zoo, and actually I think I have another friend that works there. If we go check out the elephants, they drink tons of water because they weigh tons. I mean, they're big. They drink at least 70 of these. This is a liter. So they drink at least 70 liters of water a day. Each trunkful holds 4 liters. Which is really funny if you see the elephants fighting with each other and they spray water at each other. But they also do that to cool down. They'll spray themselves in the back.
Oh,
So, we know that they drink, let's write out and try to start kind of close to here. They drink at least, what do I use for at least 70? Hayden? Yeah, they could drink just 70. Or they could drink more than 70. So they'll drink more than or equal to 70. Now, when we look at how do they drink, well, they drink through their trunk. Every trunk full is 4 liters. So we're going to take this 4 liters of water per trunk full and say, okay, they drink 4 times the amount of trunkfuls has to be greater than or equal to 70. We're asking how many times do they fill their trunk to get the adequate amount of water. So,
Grace is not here. I can copy her.
Benson's not here.
Benson's right here.
Oh, sorry, Izzy's not here, but you are. You guys are the same person in my head. I'm just But, sorry, so Benson, what do I do to get the T by itself?
Okay, so you divide
By? What do I divide by? Like, what number is going to come under it? The 4, because that's what we're getting rid of. That comes out to be the amount of trunkfuls they must consume. Break this up. Put down those calculators. Actually, nobody really reached for them. I love it. Break it into 60 and 10. 60 divided by 4. 15. 10 divided by 4, which you can think of as 100 divided by 4, then move your decimal.
25.
We get 2.5 or 25, so we get 17.5.
Wait, how do you do
Because we had 60 divided by 4 and 10 divided by 4.
Oh.
60 came out to be 15. 10 divided by 4 was 2.5. That's how I get my 17.5. I break it up and make the math easier.
Okay.
Any preguntas?
What does that mean?
Questions in Spanish.
Stop speaking.
And you get to roll your R, which is always fun. Try the got it on your own.
That's how you roll
It's a mouse.
We're switching to a mouse. I cleared it instead of capture. I'm sorry.
Or elephants are actually scared of them though.
They are. They did a test on Mythbusters.
Did you know that cats are scared of humans?
Actually, if you remind me, like at the beginning of the day tomorrow, like when I first see you in the morning, I'll show you guys the Mythbusters video where they test the mouse elephant thing.
Where's adventuring?
Huh?
Where's adventuring? I'm not.
Well, somebody remind me in the morning to pull up the Mythbusters video so I'm ready when you guys come to me tomorrow. So, we got 2 minutes.
They actually do force adventures.
A mouse drinks at least 0.042 liters of water a week. How many liters does it drink a day? So if we know how much it drinks per week, how can we relate the week and the day? CJ? Yeah. There are 7 days that he's going to be drinking to get the at least, so again, greater than or equal, 0.042. Now here's what's awesome. Is 42 divisible by 7?
Yeah.
So, just do that, but be careful with your decimal places. This comes out to be D is greater than or equal to 0.00, then 6. Yeah. So we're taking the amount he drinks in a week, because that's the whole span of the week. We're looking at just a day, so we got to divide it by 7. This is a really small amount, so that's 6/1000ths of a liter. If you look at just this up to this where my fingernail is, that's 100th of a liter. So you need to divide that amount by 10, and then take 6 of those. So it'd be like, have you ever seen a pipette? Like a dropper, like in science? It'd be like the amount that probably fits in a pipette. Like one of those little dropper doodads.
But that's a lot.
We are out of time. So we are going to wrap right there. We will pick up on the back of your notes tomorrow. Please try the 9192 homework and come with questions. I would love to go over some of that homework tomorrow and help you guys out with it.
But the thing is.
Oh, yeah, this. A pipette. This is a pipette. This is probably roughly about the amount that a mouse would drink.
But why did you have a pipette with you?
Because he stole it.
No,
Yeah, they're super duper cheap.